So friends, this is the last video on distance protection of transmission lines by Prof B Oza. And in the range of distance protection, it is number 13. In tutorial 12, distance protection tutorial 12, we have calculated one numerical. Here we are calculating another numerical which is similar but reverse. Reverse in the sense, now here we will be giving the values of K1, K2, K3, zone 1, 2 and 3 settings, and you will be required to find out the relay reach. So it is a reverse. I mean, it is interesting that if the settings are known, up to which point will the relay reach, that also one should know to clarify the subject, right? To clarify it fully. So going on, this is figure 8.47, which we will see. It shows a single line diagram of a portion of a power system network using more relay with characteristic angle 60 degree, and 3 zone settings are given: K1, K2, K3 in secondary ohms, obviously. What you are required to find out is the line length of line L2 covered by zone 1 of the relay. The line length of 220 kV line L1 covered by zone 2 of relay R from bus B. That is, parallel line is there. How much will be covered in zone 2 in parallel line? And line length of 132 kV line L3 covered by zone 2 of relay R from bus C. That means between bus B and bus C there is a transformer. There are probably 2 transformers. And coverage of zone 3 that you have to find out. So this is all what you have to find out. We'll see the figure. Relay R is there, 750/1 is the CT, 132 kV by 110 volt is the PT. The 2 plus J8 is the impedance given, and transformers, 2 transformers, 132/220 kV are given. 100 MVA transformer, X equal to 10%, there is 0.1 per unit. 200 kilometer, 220 kV line, yes, is 3 plus J18. What you have to find out is for L2, what will be the zone 1 coverage? It cannot be 100 kilometer. It will be less than that because there will be some overreach. So what is that overreach that we have to find out? And then in zone 2, it will cover L1 also. So how much L1 will it cover? And it will go into the transformer and may go up to some extent to 220 kV line, 200 kilometer. So how many kilometers will it cover in zone 2? That we have to find out. And zone 3 coverage will be what? That you have to find out. So this is how it is a reverse example. So we start ZL2 is equal to 2 plus J8. It is given 2 plus J8, right? So very, very clear. So converting into polar, it is 8.24 angle 76 degree. Now K1 is given 4.82, and therefore Z1 is equal to K1 cos phi minus theta. Phi is known, 76 degree. So it is 4.63 angle 76 degree, but it is in secondary ohms. So you have to convert it into primary ohms because relay reach is in primary. So you have to multiply by PTR by CTR, reverse. So 132 kV by 110 volt and divided by 750, that is the CT ratio. That gives me 1.6. So Z1 is equal to primary side 7.413. Sorry, Z1 means, yes, K1 is this, therefore Z1. That is Z1 zone 1 reach is 7.413 7.413. That I know. But length I am to find out. So Z1 divided by ZL2, that is 7.413 divided by 8.24. That gives me 89.96%. So roughly 90% will be covered by zone 1 by relay R. For line L2, 10% is the overreach. K2 is equal to 13.66 given. So Z2 is equal to K2 cos phi minus theta. So Z2 is equal to 13.66. Phi will remain the same because we are going to parallel line. So they are similar. So it gives me 13.13 angle 76 degree. So Z2 primary is equal to PTR by CTR. You have to multiply 1.6. So 13.13 into 1.6 will give you 21. So 21 minus 8.24, that is the line length L2. 12.76 will be covered in zone 2 by bus B. But obviously line L1 is also 8.24. So it is not so that it covers the full line length L1, but it goes into GT1 also, so to say, rightly to say. So as far as line L1 is concerned, it is covering full line length L1 in zone 2 by relay R. But now if you want to go to the 132 kV line, then to which extent it will go to 132 kV line, for that you need to know location, which you are required to find out. And when you know location, then only you can know phi. So we are under trouble. So some assumption we will have to make. And therefore phi we will take for the whole line 132 kV. That much assumption we are doing. There will not be much error. I mean, there will be hardly an error of half a kilometer or some few meters. But then you see that we have to take because phi is unknown. So ZL2 is 2 plus J8 plus 132 square divided by 100. That is kV square by MVA to convert from PU to ohms by 2 because there are two transformers. Let us see, there are two transformers. There are two transformers. So by 2. So by 2 we have made into 0.1 per unit. So we have converted in ohms plus 132 square by 220 square because relay is on 132 kV side and our line is 220 kV, which is 3 plus J18. Let us check up 3 plus J18. 3 plus J18. Yes, 3 plus J18. 220 kV square is 3 plus J18. So 3 plus J18, that is what we have done. So that gives me 3.08 plus J23.192. So that gives me totally 23.39. Angle 82.43 ohms primary. Right? Because we are calculating everything in primary. So ZL2 plus, and out of this ZL2 plus XT is 2 plus J 16.72, 16.83 angle 83.17 primary. So there our angle is 83.17. So angle is playing between 82.53 and 83.17. That I could know. Now K2 given is 13.66. So Z2 is equal to 13.66. So I am considering angle 82.43. That is the only thing you see. I am considering that full line length 82.43. That I do not know. So that I have assumed only, but that I have to do. So that I have done 82.43 minus 60. So it gives me 12.62. And if I convert into PTR by CTR in primary ohms 20.20. So zone 2 reach of relay R in line L3 is approximately equal to what? Approximately I am using the word because I made some assumption in angle. That is the only word. That is the only reason why I have used the word approximately. So 20.20 minus 16.83. Where from 16.83 is coming? ZL2 plus XT I am removing. So ZL2 plus XT. See. ZL2 plus XT. So remnant is 220 kV line. So ZL2 plus X3 I am removing. So if I remove ZL2 plus X3, from 20.20, if I remove 16.83, I get 3.37 ohms as seen on 132 kV side. But I have to see for 220 kV line, right? So 220 kV line, it is not 3.37. It is 3.37 into 220 by 132 square. So it goes 9.36 ohms. 3.37 on 132 kV side is equivalent to 9.36 ohms on 220 kV side. So if you say like that, you can say that it covers 9.36 ohms of 220 kV. 9.36 ohms into 230 kV means what? 9.36 ohms. Total it is 3.18. So little more than 18. 9.36. So roughly half of the line 220 kV is covered by zone 2 of relay R. That you can that is what you can mean. I mean, that is what you can say if you want to say so. Then if you go to ZL3, right, then it is, we have already seen that ZL3 is 3 plus. So zone 2 coverage is found out. It is 51.31% of line L3. Exactly speaking, if you want to find out, 3 plus J18, 18.24, but our reach is 9.36. So 9.36 divided by, so roughly 50%. That was what I was telling. Exactly speaking, it is 51.31% of line L3 covered by zone 2 of relay R. Now zone 3, if we come, K3 is equal to 15.82. So that 3 is equal to 15.82 cos, and now 82.43 is not assumption. It is correct. 82.43 minus 60. So 14.623, 82.43 equals secondary. Into PTR by CTR means 14.623 into 1.6 will give me 23.39 primary. And my total impedance I have calculated was 23.39, exactly 23.39, and this is also 23.39. That means relay R covers full length line L3. 220 kV line is fully covered, so it is fully backed up. That I could know, my friends. So knowing K1, K2, K3, how to know Z1, Z2, Z3. That means how to know the reach, up to which point the relay will reach. That is that important exercise we have done. With that, we end distance protection. Next, we will start line differential in the next tutorial. That is carrier current protection, differential protection of line. But distance cannot be forgotten, because most of the line differential relays are using distance. They are carrier aided distance relays. So distance is very useful, and then but distance is aided by carriers, so that both the breakers at both the ends trip simultaneously. That is the only thing. So when you talk of line differential, don't forget distance. Don't forget the fundamentals of distance. Distance is not useless. Distance is very useful. Distance protection is very useful. So with this, we will read a small sentence. B. Don't try to become. कुछ होना नहीं है. We have not to become anything. What we are is good. What we are is we are. We have not to become somebody. We have not to become someone. Someone is someone. He has his own qualities. I have my own qualities. So I am better. I am with my own qualities or disqualities. I am better. That is what Osho used to say. With that, we end this tutorial. Remembering Adapt Me. Please share this video. Please share this distance series of 13 tutorials in 13 tutorial classes. That is within 6 hours. We have learnt the theory portion of distance. Yet the mathematical expressions are remnant. And the examples, exercise, questions for you, whether you have understood distance, that is remnant. For that, my dear friends, you will have to subscribe by paying money. Module 4 of Power System Protection uploaded on Adapt Me. Right. So you have to upload the app Adapt Me from Google Play Store and search in Adapt Me the engineering division, and in engineering division Power System Protection, and in that you will find module 4. Yet it is not uploaded, but soon it will be uploaded, and then there you will be able to learn the mathematical expressions and the exercise also, and you will be able to know where you stand logically, mathematically, theoretically, everything. Where do you stand? How you have understood distance protection? That you will know. Till then, my friend, thank you everybody and good day.